in this sign, the problems are 1.5. So on this sign, we're talking about motion in 2 dimensions, not just 1 dimension. All right. So like I said to you, so let's start off. Let's just rehash this really quick, so we won't be totally lost when we start talking about the equations, right? So the reason why we've been doing vectors, right, or the last couple of exercises we did with the vector A plus B plus C, right, is because when we have a vector, right, on a Cartesian coordinate system, this is what? This is X, this is Y, right? So the speed of an object, right, we call that V, right? V. It's a vector, meaning, or the velocity of the object, not speed, the velocity, right? So the velocity of an object can look something like this, right? When I kick a football off the ground, right, it looks like this. Am I right or am I wrong? When I kick a football, does it go straight up and then fall back down? No. Does it go straight forward and doesn't go up at all? No. It goes what? Somewhere in between those two. At a what? 45-degree angle, right? This is typically about 45 degrees. That's for the maximum range, right? So, remember what we said, whenever we see this, we do what? We could draw what? Our projections. Remember that? What projection is this? This tells us how far the vector V moves along which axis? X. So this is the X component. Right? Y'all following that? Everybody understand that? So this is the what? The Y component. Remember that? And we know from what? And we don't necessarily know. Let's not say that this is 45. We're just gonna call this theta, right? Now we know from our what? From our trigonometric identities that what? Vy is or the sine. Let's say the sine of theta is equal to what? Right, opposite over hypotenuse, right? Hypotenuse, which is what? Vy over, what's the hypotenuse of this triangle? What does it mean? What is a hypotenuse? What does it mean? What is the hypotenuse of a triangle? Huh? The longest side of a triangle, of a right triangle. This is a right triangle, right? So which is the longest side? Huh? The one in the middle. Huh? How about the diagonal line? How about that? So this is the hypotenuse of a triangle right here. Right? So when we have a triangle, we remember this from advanced math. Right? This is CAB. Right? And what? A squared plus B squared equals C squared. And C is the hypotenuse. Hypotenuse. This is the longest side of the triangle. So here, the longest side of the triangle is V, the actual vector. Right? So they said, oh, the speed of the object was traveling at 30 meters per second at a 30-degree angle. Then it's going to be what? Your V, so this is V, going to be 30, right? 30 meters per second, but Vx is going to be what? Vy is going to be what? Vy is going to be what? V times sine of 30 degrees. That's if theta was 30 degrees, right? Theta was 30 degrees here. Then Vy would be what? V, and let's say this was 30, so you would have what? Equals 30 times sine of 30 degrees. Y'all following that? Vx is going to be what? Huh?
30 cosine
30. Well, let's write out the equation so we don't confuse anybody where it came from.
You said A and C, the legs?
I said what?
You said C is the hypotenuse, and A and B are the legs?
A and B are sides of the triangle. C is the hypotenuse, right? And so the cosine of 30 is equal to adjacent over hypotenuse. Hypotenuse. And that's what? Vx over V. So then that would come here. That's what? V times cosine 30 degrees. That would be what? 30 times cosine 30 degrees. All right? So, whenever we describe the speed of an object, we can break it into x and into y. And this is how we do it. Right? So, the first question, right, is, let's see. Right. So, that's just a little rehash of what we've already done, right? So now let's talk about this question. A ball rolls off a table 80 centimeters high with a speed of 2.4 meters per second. How far will it travel horizontally before striking the ground? I got the roll going around.
Yeah, the roll?
That's the question. Right? Ball rolls off a table 80 centimeters high with a speed of 2.4 meters per second. How far will it travel horizontally before it hits the ground? Right? So we got all this by now, right? If we don't, let's take a picture of it so I can go ahead and erase it. All right? Better get it.
Yeah, take it for yours.
But all of this is being recorded, so you can go back and watch the video, remember. That's why I record them. So you can go back and watch. And some people need a couple times to watch these things before it sinks in. So, we're back to our problem solving approach, right? What is the problem solving approach? What's the first step?
You got
Say
80
again?
centimeters high.
No, that's not the first problem. This is the first step in the problem solving approach. Identify the problem. What are we solving for? What are we looking for?
How far we travel.
So what does that mean?
So, I don't know if that's what free fall is, but. It do got field,
Okay, so the, why
So
is
let's
it
answer the
outside?
question first. The first question is, what are we solving for? Distance. Horizontal distance.
You can use that.
No, it's an equation. We do.
And I'm gonna be adding more problems on mastering today, after today, all right? On projectile motion. Horizontal distance, and what do we normally denote horizontal distance as?
X.
X,
It's still gonna be,
Oh,
right? So that's what we're looking for, X. And that's normally in what? Meters, right? So number 2, time scale, whatever, we'll say seconds. Doesn't matter. 3, what's the third step? Huh?
see, all the, this is when we get all the information.
The
It's
givens,
in the side.
right? So we write down the givens. So what are the givens? So what are the givens?
80 centimeters wide and 200.
What is 80 centimeters high?
That is, 20 something meters.
What of the table?
The ball rolling on the table. The ball rolling on the table, 80 centimeters.
What is 80 centimeters? What does that represent? The what?
The height is high.
You said, I thought you said light.
Oh, no, it's
Yes,
height.
the height. So the height of the table, we'll call that Y, right? Because it's what? Y represents vertical. What else? And we have a speed, and we'll call it the initial speed,
So we,
meters per second. That it?
wait, we got something.
We got gravity, right?
Right.
We're coming off of a table, so it's going to be affected by gravity. Right? So step 4 is to do what? Cartoon, right? So we had a table here, alright, some legs, maybe a little grass there. Here's the ball. The ball is rolling. It has speed of 2.5.4 meters per second. So when it comes off of here, it's gonna come off like this, right? Boom, right? And so here is where we wanna know what's the distance from here, right, to here, which is our what? Horizontal distance, X, and from here to here is our what? Vertical distance, Y. Does that make sense? So the first step, since we know we're dealing with vectors, is we're going to take our speed and we're going to break it into speed in the X, speed in the Y. Right? So, when I'm coming off of a cliff like this, if I roll something off of a cliff, it is the equivalent of free fall motion. Right? I'm telling you. Right? So when you roll something off of a cliff, it is the equivalent of dropping it off the cliff. The reason why is because the initial speed of the ball in the Y direction when it comes off of the cliff is what?
2.4.
Nope.
Or is it, wait, you said the y direction?
In the y direction.
Oh, 0.
0. So V O in the y direction is 0 meters per second. So V O in the x direction is what? Huh? What's it in the x direction? 2.4. Right? So, in the y direction, we know it's undergoing what? Free fall. So then we know we can use which equation? Huh? Yes. Y is equal to 1/2 GT squared. And we can rearrange this equation for what? Time. Right? We know everything. We know what the Y is, 80 centimeters, and we know what G is, so we can get time from here. Somebody tell me what that time is. Right? Because if I do, so my time is going to be equal to what? 2y square root of 2y over g. That's what my time is going to be.
What's the conversion factor for centimeters to meters again?
Say it again.
Centimeters to meters, what is that?
Why are we doing that? Oh, you got to change that. Yeah.
So centimeters to meters?
Yeah.
It's 100 centimeters.
Okay. So it's
2 times 0.8 divided by 9.8 square root. What is that? All right, it's not enough just to write this down. We need to be using the calculator and practicing this. All right? So I'm just letting you know. So when you get on the exam and you have issues with your calculator, don't ask me nothing. Anybody?
let's see. Right, I got 0.4.
That's possible.
So that's what I did. Okay. Yeah.
4.0.
Yeah, 0.4. That's 8.4. Yeah.
4.04?
No,
No.
0.4.
Okay.
It's 0.4. So it's 80 centimeters, and then you convert that to meters, which is 100. So 80 over 100 is 0.8 meters. And then times 2 divided by 9.8, and then you put that in the square root.
But would you not divide 80 by 100?
Is that right? Or is it?
Because it's 1 meter
Mhm.
equals 100 centimeters.
Yeah, and that converts to a meter.
Right. So,
Because then I mean, if
Centimeters
you
is
multiply it, then
smaller
it'd be 800 meters.
right. So y'all got 0.8, right?
Yeah.
What is it first?
That
thought
turns
it
the
was
centimeters into meters. You see, because you write on paper that's top. You put the 80 on top, when you're trying to convert, and then you put 100 centimeters on the bottom, and that's 1 meter. And then you cross it out, and then you get 80 over 100, and that's meters.
What was it? What's the number?
I got Oh wait, that's different now. I had 0.4.
So what is it?
0.4 seconds.
0.4 centimeters?
No, seconds.
0.4 seconds. I need somebody else to get 0.4 seconds before we can move forward.
What you think you're gonna do?
Oh, I'm not even doing that. I'm taking the test.
Oh, I was supposed to. Oh, right. I didn't know I was supposed to do that.
You know you're supposed to what?
I didn't know
I can't hear you.
that.
Oh. All right, so we're at point, somebody got 0.4?
Yeah, I got it.
Okay. So we got 0.4 seconds. So what is that? What does that represent?
How long before it hits the ground?
How long before it?
Free fall direction.
Okay. How long before it hits the ground? In which direction?
Y.
And
X.
X. Right? So if I know the time and the X, and I know the speed and the X, then what?
But you can put that all into another X, because another X in horizontal is 2.4 meters per second.
That's not X.
Oh wait,
No.
it's only in the horizontal.
X is what we're looking for.
Oh, as in distance, my bad, the velocity
Okay.
is 2.4 meters per second, and we know the time, and that's in the X direction, you know, the time that before it hits the ground is 0.4, so we put the equation for,
Yes. So that's the first equation we went over when we, right? Now we know the time, right? Time is equivalent in X and Y, right? So if I want to know X equals V in the X times T. It's that simple. And what is V in the X? 2.4 meters per second times 0.4 seconds. And what is that? What is that? 9.6?
Yeah.
9.6 meters. Oh, not 9.6 meters.
yeah,
Nine.
0.96, yeah.
Plus that, multiply by
Huh?
no.
All right? Let me go.
Um,
No, I got that. I'm talking about the one before here. When y'all got 0.4 seconds.
You gotta put everything under your right.
Then what? Oh, okay.
Everything gotta be under the right. So you gotta like, so what I did was I divided the fraction first. And then I put it under the right.
right, so they starting to get a little more complicated, right? Oh, excuse me. All right. How much time we got? This one, 20 minutes?
Yeah.
Oh, no, we got it. Oh, yeah. That's enough. All right. This should take us out. An archer standing on a cliff (48 meters) above the level field below shoots an arrow at an angle of 30 degrees above horizontal. With a speed of 80 meters per second. How far from the base of the cliff, or from the base, of the cliff, does it land? Will the arrow land? All right, so we got a lot going on here, right? So as I mentioned to you, these are little soap operas. Each problem is like a soap opera. Right?
Lots of, yeah, lots of singing.
You say what?
There's lots of singing.
Oh. But yeah, no singing. All right, so what's the first step?
Find the question for.
You gotta do better than that, brother. It's 30 minutes late. You might as well miss the day. What is it?
Find the question for.
What is it?
The distance the arrow travels, so X.
You say the distance that the arrow, so horizontal distance, right? X meters. Yeah. All right. Time scale, we're gonna skip time scale. All right? Not really important here. We're talking seconds. Okay? Givens, right? What are they?
We got the on the cliff, 45, I mean, not 48, 48 meters above,
What is 48 meters?
Y.
48 meters is gonna be our Y, right? So Y is equal to 48 meters. What else?
Even though it's at an angle of 30 degrees.
So we got a theta, we got a theta of 30 degrees, right? And what else?
Speed.
We have a V of 80 meters per second. All right. Anything else?
Gravity.
Gravity. I need y'all to recognize that. Drawing it off of a cliff. So it is undergoing gravity or experiencing gravity. All right. Now what? First thing we should recognize, first thing we should do. Right? This is what? This is the initial speed. So what should we do with that? Into X and Y. So VO is 80. VO, well, yeah, let's do that. VOX and VOY. So let's draw the diagram, which is step 4, right? So we on the cliff. Guys on the cliff, right? And the cliff is what? 48 meters, right? 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 48. And the guy shoots the rocket or the arrow off of the cliff. Hi, y'all. Right? So this is the trajectory that the arrow is going to take, right? It's going to go up and it's going to come back down to the ground. Right? So it's what? This is the distance we're looking for, right? Where it's you show me where the distance we're looking for. And you say it again.
Where the arrow is?
Where the arrow lands. I need you to be descriptive though. Like that's not a complete sentence. Where the arrow lands is not. That don't tell me nothing. There's a complete sentence when you say things. Follow what I'm saying to you? Okay, you look like you looking at me like you don't know what I'm saying.
I mean, I know, but I don't know how to rephrase it.
You don't know how to rephrase it. I said what? So listen. I said, what are we looking for? You said where the arrow lands. I know what you're trying to say. That's not exactly correct though. What are we looking for? Where the arrow lands is a location. What are we looking for? Huh? A distance. So how do you describe a distance? From one spot to another spot. That is a distance. See, physics is not going to get easier if we do the same thing we've been doing all the time and just talking generalities like we talk on the street. It's going to make this stuff harder. You have to be very intentional. You have to be very specific about what you say and what you do. So I know some people are I've had it in the past. Some people take it personally. They think I'm picking on them. They think I'm picking on Dr. Stewart picking on me. No. I'm trying to show you how this becomes easier. As if you have to be very specific about what you're doing and and you have to say it to yourself. Right? I know what you're trying to say when you say where the arrow lands. But no. What you're trying to say is, or what we're trying to say, we're trying to find the distance between the base of the cliff and where the arrow lands. That's what we're trying to find. Not where the arrow lands. You following what I'm saying now? Gotcha. Alright, so we're trying to find the distance x. Okay? Studying physics makes you a better communicator. Telling you. Right? Because a lot of things we say in the world are really like very, like when we say, how far is New Orleans from here? Somebody gonna tell you, well, oh, it's about an hour. How far is New Orleans from here? Yes, that's the distance. You can't say time. You can't say, if I ask you how far something is, you tell me it's an hour. Yeah, that's not a correct thing to say. You see what I'm saying? But you know, because that's like colloquial, right? That's how we do. And we might express distance as time. Just out in the world, right? But in physics class, if you say distance, you gotta have distance. Can't have it as time. It'd be a wrong answer. Okay? So we're looking for distance, x, right? So what we're gonna do is we're gonna do like we did with the triangle, right? Here's our arrow coming off the cliff. Here's V, right? This is what? What is this? VOX. The x component of V. What is this? V, huh? VOY, yes. The y component of V. It tells me how far the vector V goes in the y direction. Just like VOX tells me how far the vector V goes in the x direction. Y'all see how I know these definitions? I have committed them to my memory. I could never forget them. But that takes time, and it takes slowing down and saying it to yourself. So now, if I say something incorrect, I could catch myself when I say incorrectly, because I've been slowing down and training myself. That's how you got to do it, at least for this semester. Right? So we're gonna do that here, right? So what's the VO and the X is gonna be what? Huh? 0. 80.
VOX is
It's not 80 cosine 80 degrees? That's not it?
No, you did that because the last one was 30 sine 30 degrees. No, that's not. No, you're missing the understanding here, right? This is the angle right here, right? Right? It's not gonna be 80. You say 80 cosine 80 degrees. That's what.
30, I'm sorry.
Yeah, this is 30, right? So the angle it come off is 30, right? So it's gonna be 80 times what? Cosine of 30 degrees. What's VO and the Y?
80 sine.
80 sine 30 degrees. It ain't but two of them, y'all. So this tells me how fast my object was traveling in the X direction, how fast it was traveling in the Y direction. But to actually describe the motion of the object, I got to put those two back together. That's why I call them what? Projections. They are projections. They're not the real thing. They are projections. So, Yeah. So now, this is a problem. So this is. So I'm gonna tell you the reason why I chose this problem is because we're gonna use a quadratic equation here. Okay. And I don't know if everybody in here is familiar with the quadratic equation. If you're not, you're gonna get familiar with it because we need to understand how the quadratic equation works in projectile motion. Okay. So when we come off this cliff, so the difference between the first and last one we did is what? The ball did what? Rolled off of the cliff. He shot the arrow off of the cliff. So when the ball rolled off the cliff, it's gonna do this. Boom. He shot the thing. Right? But the physics here is what you have to recognize, right? So because he shot it off the cliff, right, and it's undergoing what? Gravity, right? In the y direction, it's experiencing what? Free fall. These are the discounted health plans. It's experiencing free fall, so we can use this equation right here, right? Y equals y naught plus v 0 in the y times sine beta t, right? Minus 1/2 gt squared. That's the free fall equation, remember? So when we were doing, the only difference is we added the sign here because now we're talking about 2 dimensions instead of just 1. When we had 1 dimension, it was just this, right? Y equals y naught plus what? V O y t minus 1/2 g t squared. Okay? So this is the free fall equation, right? Free fall. Right? This is the free fall and for 2 dimensions. 2D free fall equation. Right? So we just gonna have this y 80 sine theta 30, that's gonna go right here, right? So let's start, so I'm telling you this is what you're gonna use, so we could just go ahead and start plugging these numbers in, right? So I'm gonna erase this one. Okay? So y is what? 48. Right? And what's the initial distance that the arrow travels in the y direction before he shoots it? 0. VO in the y is equal to, well, I wrote this wrong. I take the sign. I just see VO in the y times t. Because that includes the sign. Minus 1/2 gt squared. This includes the sign, so here's 80 sine 30 t minus 1/2 9.8 t squared. Right? So let's write that a little cleaner. It's a little messy. So we don't have any confusion when you go back and look at this later on your own. 48, this is 0, plus 80 sine 30 degrees times t minus 1/2 9.8 meters per second squared t squared. All right? So now, if we remember anything about fundamental theorem of algebra, right? Now I bring this over here, right? 48 to the other side. Huh? Subtract it, right? And that's gonna leave me with what? So I'm gonna leave what? I'm gonna start from the right. I'm gonna write from left to right, but starting from the right. All right, y'all. So this gonna be what? Negative 1/2 9.8 meters per second squared t squared, right? Plus 80 sine t, right? Minus, right?
Oh, minus.
Minus 48 equals 0. Now this right here looks like this, right? X squared plus bx plus c equals 0, right? This is the what? Huh? That's the standard form of the quadratic formula. Yes. The standard form. Yeah, that's what that is. And we got that back in 7th grade, 8th grade.
I still remember the G.
Hello? Who you talking to, bro? Hurry up, man, I'm in class. Huh? Oh, all right. Yeah, this is the standard form of the quadratic equation. All right? And so what's the solution to the quadratic equation? Huh? What? X is equal to minus b. Huh? What is it?
It was 7th grade.
Minus b, what is it, y'all? What is it? I forget it.
C squared minus 4ac square root of c squared.
Negative 2 plus or minus square root
Let's ask Mr. Google, man, just to be.
I literally had
All right.
18-year-old YouTuber.
We gonna verify.
Played it in class like 17 times. And it's
Solution to quadratic equation. Yes, sir. Yep, minus b plus or minus square root b squared minus 4ac all over 2a. That's the solution to the quadratic equation. Alright? So, here, what is A? What's the number? What we calculate? There's nothing to calculate. That's why I wrote this down here. A x squared, this is t squared, plus bx, t would represent x here. B would represent what? Huh? 80 sine. So A would represent what? And what else? Negative 1/2 and 9.8. Right? So that's what A is. All right. Well, let's not put it yet. Okay. So, or we can put it, and I'll show you where it comes from. Right. So it's negative, because we're gonna end up changing A. We're gonna make A positive. But when you make A positive, you got to do what? Make B and C the opposite sign too, and then it's the same thing. All right. So A. So before we make it positive, let's just write it how it is here, right? So it's negative what? Negative 4.9, right? 1/2 of 9.8. And this should be 30, right? Sine 30 degrees. T. What's that number?
40.
40. Alright, and C is 48, right? Okay? Oh yeah, negative 48, that's right. Negative 48. Oh, it's 12:53? Alright, yeah. Yeah, we'll stop here and, what's the date, Wednesday? Yeah, we'll finish this on Friday. Alright?